Good morning to all the participants from Andhra Christian College, Guntur. I welcome you all to this two-day international webinar on health, environment, and educational aspects of COVID-19 on 15th and 16th June 2020. This is a joint venture organized by the Department of Botany and Internal Quality Assessment Cert. I just want to share some of the instructions to the participants. The Zoom link is connected to given to you. You can log in from Zoom, and the meeting ID is given to you. The meeting password is also sent to you. Then if you are unable to join the Zoom link, you can move on to YouTube. That is automatic. You can also view our program on the YouTube live and also on the Facebook live. So you can, if you are not able to get into the Zoom, you can also view on the YouTube as well as on the Facebook. Kindly mute your microphone and also switch off your videos so that there will not be any interruption throughout the program. And if you have any queries to the speaker, please post them in the chat box and the same will be addressed at the end of the session. And the feedback form link will be posted in the chat window of the Zoom and YouTube live at the end of the session. So please fill the feedback form and send it back to us, and you'll be provided with the e-certificates after submitting the feedback form. So kindly make it a point to send back the feedback form on time. These are the few instructions to the participants. Now we shall begin the program. This is the first day, session 1, Monday, 10:35. We shall start the program with the opening prayer with by Dr. Mrs. Sajani Lavanya, lecturer from the Department of Mathematics.
Let us pray. Gracious Heavenly Father, we praise you and thank you for this wonderful day. Lord, I seek your guidance as we gather in your presence on the occasion of this international webinar program. Be with all the staff who are engaged in conducting this program. Lord, I pray for the resource persons who are going to take the sessions as they are prepared to share their knowledge. Lord, I also pray for all the participants, bless them in all aspects. May this program help all of us to understand the insights of health, environment, and educational aspects of COVID-19. In Jesus' precious name we pray. Amen.
Thank you, Sajani. Now the next is the chairperson's opening remarks. I won't take much time, but there are some things which I wanted to share with you. Again, I welcome all the participants, especially the lecturers, the staff members from other colleges, from our college, some of the alumni, some of them from the education background, our students. A hearty welcome to all of you. On behalf of the management, staff and students, our college, I welcome you to this age-old college with a heritage status, a 135-year-old college, a college of great reputation, which has produced stalwarts in various fields. And our college, the Andhra Christian College, was a beacon of hope in the yesteryears for the underprivileged and marginalized sections of the society in providing education with values, showing God's love. And this college was started by the American missionaries and founded on great values. We continue to show his love by working here. And a warm welcome to all of you. Uh, uh, I especially put on record the efforts of Dr. Ezra and Dr. Moses, Dr. Sajani Lavanya, and others who are all engaged in bringing this to a reality. I congratulate them. And webinars like this help us to have better understanding of the issues and the problems we are facing during this pandemic time. And it also helps in equipping ourselves with the knowledge, and also acquiring us, helps in acquiring knowledge about the e-tools which we are using or which we will be using in the classroom teaching. The future classrooms will be full of these tools, and these are going to become the new norm. And the thing is, we have so much of knowledge around us. The only thing is we have to absorb it and apply it so that we get better results. And it also gives a lot of satisfaction to us. Yesterday I read something like this: continuous improvements are better than delayed perfection. So as teachers, as lecturers, we are supposed to be continuously improving ourselves. Continuous improvements are better than delayed perfections. So webinars like this help us to improve our knowledge. And for knowledge, there is no age limit. There is no limit for learning, and there is no limit for understanding. So there's nothing, no hindrance. Everybody should be a lifelong learner. It is a continuous process, and we learn from each other. I'll just end up with the quote from Nelson Mandela: "Education is the most powerful weapon which you can change the world." I repeat once again: education is the most powerful weapon which you can use to change the world, by Nelson. Then we go on to the introduction of the resource person. The resource person is Dr. Johnson T. Samuel from UK, right? And our dear Dr. B. Ezra Vijaya Sekhar will introduce the resource person to us.
Good morning, everybody. I am Dr. Ezra Vijaya Sekhar, HOD, Department of Botany, Andhra Christian College. It's my immense pleasure to present the brief resume of Dr. Johnson T. Samuel, MD, DNB, FRCP, PG, FHEA. Dr. Johnson Samuel hails from Chennai. After schooling in Chennai, he graduated from the Christian Medical College and Hospital, Vellore, India, with an MBBS and MD. Dr. Johnson Samuel has been a consultant respiratory physician at Basildon University Hospital from 2004. He is the Director of Medical Education for the Mid and South Essex University Hospitals Group and the lead for Pulmonary Physiology, Sleep Medicine and Ventilation at Basildon University Hospital. He was elected a Fellow of the Royal College of Physicians, London in 2008 and Fellow of the Higher Education Academy in 2010. He is an examiner of the Royal College of Physicians and is an honorary clinical senior lecturer of the University College London. His specialist interests are in sleep medicine, non-invasive ventilation, and cardiopulmonary physiology. He has developed the cardiopulmonary exercise service, which is used to widely by physicians, surgeons, and anesthetists across the regions. He presents regularly at national and international conferences, has publications in peer-reviewed journals, and has authorized chapters in a respiratory textbook. He has been part of working committees of the British Thoracic Society, Royal College of Physicians, London, East of England Multi-Professional Deanery, and the East Anglia Thoracic Society. Dr. Samuel is passionate about educating and training. He oversees medical education and training in the 4 SISET hospitals. He regularly teaches medical students, postgraduate trainees, secondary and primary care physicians and nurses. He has organized a number of medical educational and respiratory symposia in the UK and overseas. Dr. Samuel is passionate about his faith, family, cricket, and work in that order. He tries to treat patients holistically using patient-centered, evidence-based care. He believes medicine is a vocation and its practitioners lifelong learners. Thank you very much. Thank you very much, Dr. Johnson Samuel Garu. Announce చేస్తాను చెప్పేసానా మేడం మరి నేను Now I request Dr. Johnson Samuel to deliver his lecture.
Thank you very much, Dr. Ezra Sekhar. I'm delighted to join all of you today in this webinar. Can you all hear me? If one of you raise their hands, it should be okay, if you can hear me. Can you all hear me okay? Okay, I presume you can hear me. I'm delighted to join you this morning. In the COVID-19 period, thank you for the resume you read as well, Dr. Ezra Sekhar. The organizations in India, I've worked with the Christian Medical College in the COVID-19 outbreak to give them information from here, because we have come to this pandemic well before the Indian pandemic has set about, and also working with mission hospitals in India and sharing information and trying to help. So I'm delighted to actually join Andhra Christian College, and I must say that I have been in Andhra for a year after I finished my MBBS. I worked in Ambajipeta in East Godavari district, Christian Hospital Ambajipeta, for a year, and I enjoyed the people. I enjoyed traveling around Andhra Pradesh, and it gives me great privilege to speak to you today. So what I propose to do is to give you an overview of the SARS-CoV novel coronavirus pandemic. And in the next half an hour, I would hope to do a few things, really 5 things. Firstly, I would just tell you a bit about the basic understanding of the virus. Secondly, I'll just tell you about this pandemic in perspective. You know, where are we now? Has it happened in the past, and what's likely to happen in the future? Just give you an overview thirdly about the clinical presentations and how does the disease progress. Give you some idea of the treatment, that is the prevention and management of cases. And finally, I'll give you some speculations about where we go from here. So I do understand this is a diverse audience, and we have faculty of sciences and commerce. I was looking at the participants. So I will try to make it as general as possible. And in the question time, if you ask me any questions in detail, I would be very happy to go over the questions in detail. So firstly, I have to give you some disclosures. you may have seen the brochure and you may have seen me with a beard. I can tell you I'm the same Johnson Samuel. I had taken my beard off for the pandemic because I can't wear my N95 mask with a proper seal with a beard. So I had to take my beard. So I'm the same person. I'm a respiratory physician. I work in Basildon Hospital, which is the front of the hospital, and this is the cardiothoracic center, which is also a part of the hospital, and that's where I work. My office is, my cardiopulmonary lab is in the cardiopulmonary center. And this is an overview of Basildon, and on the top of this, the picture on the right, and London is on the right here. So we're about 10 miles outside London. I must say I have been in the thick of the pandemic. The pandemic hit the United Kingdom in the 3rd week of March. And we have now gone to the peak, and we are actually on the slope downward. For example, at the peak in mid-April, we were treating approximately 180 patients in our wards and 40 patients in intensive care just in our hospital. And across our 3 hospital sites, we are treating something like 350 patients. Ours is the largest site and the largest intensive care in the 3 hospital groups that we are part of. Currently, we only have 22 patients in the ward and 9 patients in intensive care. So it's come down significantly. So during the course, because I'm a director of medical education, I was also involved in redeploying our trainees. You know, people had to move from gynecology, for example, and our trainees were moved to help in the emergency department. People who are working in departments like pathology and radiology were moved to intensive care. So we redeployed our trainees so that people are there at the front end where most patients were. And I must say it was a great experience, because the way the medical workforce we have in our hospital, for example, about 170 trainee doctors. These are postgraduate doctors, not undergraduate, postgraduate doctors, and about 150 doctors who are not consultants, who are on the way to be consultants. So about 300 doctors we were able to redeploy, and people went and worked without asking any questions. And I was very, very impressed with that. And finally, we are all learning, and I have just submitted an abstract on our experience with ventilating patients to the European Respiratory Society and writing up one paper. So I have been in the thick of the pandemic, and I can give you an overview. And I'm going to give you some of the things that I've shared with CMC Vellore and the mission hospitals, but not going into the medical details as they would require. Okay, so to start off, you know, what is this bug? What is this virus that we are looking at? So it's called it's coronavirus disease 2019, or otherwise COVID-19. Now, these coronaviruses, as you know, many of you are zoologists and biologists, are a large family of viruses which are present and causes mild to moderate respiratory diseases, chest diseases. Now, this COVID-19 belongs to a specific genera called beta coronaviruses. And over the last 2 decades, 3 beta coronaviruses have come up from animal reservoirs, jumped onto humans, and caused major disease and death. You'll recall in 2002 to 2004, we had the SARS epidemic in China, the Guangdong province in China. And that jumped from some exotic mammals, like the Himalayan civets and the raccoon dogs, and quite a lot of people died, 2002 to 2004. Then in 2012, we had the MERS COVID virus, which came from camels in the Middle East. Not many people died, but not many people died in all, but people who were infected, lots more people died. We still have sporadic outbreaks. And in 2019, the coronavirus, it's called the SARS-CoV-2 2019, which is why it's called COVID-19. It emerged in the Wuhan province in China and declared a pandemic by the WHO in March this year. Now, this is a single-stranded RNA virus, and it's got a certain structure, and that's how it looks. This picture on the left is created by the Centers for Disease Control. Those of you who are biologists may be interested. The structure is like a corona. It's rounded and it has got spikes on the outside, which gives a look of a corona. And there are some proteins which you can find outside the cells. So we're not going into too much detail, but the good thing is scientists were able to crack the genome of this virus very, very quickly. And this is an electron microscopic study of how the virus looks like, and looking into the cell. These are the blue pictures of the virus in the cell. And we know that this is how it transmits from the bat. This is our understanding currently. By direct contact, it comes across to intermediate hosts, and then by direct contact, it comes on to humans, and by droplet and aerosol contact, human-to-human transmission. So that's the sort of transmission we had from the animal kingdom to the Homo sapiens, that's us humans. The next thing which I said we will look at is, look at this pandemic in perspective. Is it the first time the world is coming across such a pandemic? Have we been here before? Actually, we haven't. We've been here numerous times. The first recorded pandemic in history, when there are records, is in AD 165 to 80. There were lots of pandemics, I'm sure, in the BC era, but this is the first recorded in history, is the Antonian plague, or the plague of Galen. It is in 165 to 180 AD. Nobody knows what exactly the disease was, but they think it could be smallpox. And about 5 million people died because of that. Then there was the plague of Justinian in 541, which is the bubonic plague, and about 25 million people died. That's a lot of people. And the well-known plague is the bubonic plague, Black Death, in 1346. About 70 to 100 million people died. And you will know that there are a lot of Christians who were involved in that and caring for people at that time. In the 19th and 20th centuries, we have the cholera pandemics in India, in the Indian subcontinent. More than 1 billion people died in these pandemics. Earlier, the last century, we had the Spanish flu, which is an influenza virus killing about between 15 to 50 million people. And the picture on the right is actually a black and white picture of how the hospitals look like when you had the Spanish flu. People were just lined up, next to each other, and people were dying like flies. And nobody talks about the AIDS pandemic, but AIDS is also a disease which initially came from mutated virus in the monkeys, and that killed almost 32 million people. Those are all pandemics. And then there are epidemics, which are local, and we had the Ebola and the SARS epidemic, and so on and so forth. This is the map of the COVID-19. This is updated as of 11th of June, which is last week. So just giving you the World Health Organization picture, and this is taken by the CDC and looking at all the cases. And if you can look at the blue ones are the hotspots. Now we are saying they are new cases. You can see India, they're coming up new cases, lots of new cases coming all across the world. And if you look at the yellow ones, that's where you have lots of more than 2,000 cases, which have been described. So that's how the world looks like. And if you look at how it looks like in the deaths from COVID virus, the US actually tops the list, gone more than 100,000. UK as of yesterday, it's about 43,000. I'm not exactly certain about the numbers in India, but other countries like Australia have very few deaths. We're talking about the Western world here, not really talking about India. And I know, looking at the newspapers yesterday, the numbers of deaths vary from newspaper to newspaper. So I will leave it to you for speculation. So as of 11th June, this is the confirmed cases, just under 7.5 million, about just under 3 million are recovered, and about 500,000 people have died from the virus worldwide. So when you put this pandemic in perspective, we are not anywhere near some of the pandemics that we've had in the past. Okay, so I've told you briefly about what the virus is and the pandemics. It'd be worthwhile looking at the presentations. How does it present? Now, it's useful to know the transmissions because there are 3 big ways it transmits. 2 of these are airborne, which means it's transmitted by the air. And secondly, it can be transmitted by a contact with fomites. So when we talk about the airborne, we have droplets, which is the airborne. I'll tell you about it in a minute. Aerosols, I'll tell you about it, and contacts. And this is based very simply on the transmission patterns we've seen in the previous SARS outbreaks, because these are all coronaviruses, as I said, and they haven't actually looked at the number of patients who can transmit by contact, for example. But we know it happens because coronavirus is transmitted by contact. And this picture on the right gives you an idea of the aerosols which go across, and we cough, then it goes for the air, it goes into the respiratory tract and so on. And then it goes on to fomites like television or phones or whatever you may be. And then you can goes again through the airborne. So the infection enters, whether you touch it or not, via the airborne airways. So you can't eat and get the disease. It has to go through your upper respiratory tract. And this is another picture showing, you know, what's called as aerosols. For example, why are the dentists closed? Because dentists were closed because when you drill the teeth, you develop aerosols, very fine particles, and that can also go on the airborne route. So what do you mean by droplets? Droplets are large particles, more than 5 micrometers in secretions, and they contain viruses. And they usually come when you cough or sneeze, or for example, if you shout or you sing. So these are big droplets, and they can travel for just under 2 meters, which is why you talk about a 2 meter safe distance, which the West has been talking about. So droplets can, you know, travel up to 2 meters, and they tend to fall to the ground very quickly. The other thing about this 2 meter, the droplets, when you wear a mask, the biggest effect of the masks, that we're talking about the surgical mask now, when you walk around, when you talk about masks, the surgical mask as in prevents the droplets going far away, because when you cough, it hits the mask. It doesn't so much prevent you getting the infection, but it may prevent some droplets when actually hitting your face and that sort of thing. But usually it is to prevent me giving the infection to somebody else if I have it. And that's a picture of a cough, if you can look at it. Just when you cough, it gives you a turbulence of air, and it travels at the speed of 18 miles per hour. And there are several phases of the cough. So you have the initial cough, and there are some droplets which hang around. And then some of the cough, I said, produces droplets, but there may be there are various stages of the cough. So you can have a few aerosols there as well. So that is the transmission by cough. And if you look at the transmission by sneeze, a sneeze is actually, this is a picture of a sneeze. All of them are done in Massachusetts, in Boston. It captures the sneeze in 20-second intervals going across. The interesting thing about sneeze, and this is about 150 milliseconds going across the top row. The largest droplets, when you sneeze, it settles 1 to 2 meters away. But the smaller droplets and evaporating droplets are trapped in a puff, as you can see in the lower bits. It's trapped in a puff, and it remains suspended. It can go even up to a few minutes after a person sneezes, and can travel sort of the dimensions of a room, for example, 6 to 8 meters away. So a sneeze can actually last much longer than a cough. So cough and sneeze are actually pretty important in the transmission of these viruses. So that's the droplets, the cough and sneeze, and then is the aerosols. If you think of an aerosol, it's like a fog or a mist or dust. It's very fine. It's much smaller than droplets, less than 5 micrometers. And if you look at the COVID-19, it's very, very small. It's 0.007 micrometers. It's a very small virus, and it can deposit deeper into the respiratory tracts. So because they are very small, they can easily travel. And these can travel in a straight line. It cannot travel in a straight, it can remain suspended, but doesn't travel like it remains in the air. As I said, after a sneeze, some of these aerosols remains in the air. And it's generated by some special procedures. We call it as aerosol generating procedures. And the classic one, which everybody knows about, is the dental chair, when you drill the teeth. Lots of other procedures in the hospital. For example, when we, people have a mask, we have ventilation, we have nebulizers, we have, we give non-invasive ventilation, we put camera tests inside. All of them produce aerosols. And the interesting thing about aerosols as well, aerosols needs a minimum of 20 minutes for it to settle. So it's much longer than a droplet, which can settle pretty quickly. And what we talk about in medicine is you need air changes in a room, for example. What is the ventilation? All these are important because the longer you have contact with people, the more chance you have. And the longer it stays in the environment, the more chance that you can get infected. So that's what it means. So there are various procedures in hospital. For example, in my lab, we do, in the pandemic period, we did urgent lung function tests where you ask them to blow into a machine. So when people cough and they can generate procedures, obviously my staff wear full PPE clothing. But we don't bring the next patient in for almost 2 hours because we want to make 6 air changes before the next person comes in. As you can imagine, in my lab, we do about, in each of my rooms, we do about 8 to 10 tests a day. Each of these tests lasts between 30 to 45 minutes. And if you're going to be doing only one test every 2-3 hours, the number of tests we can do are very few. So we are looking to see what happens post-pandemic. Can we say that we are all clear? Can we say every patient walking through the door is clear? No. We'll have to see how quickly we can change the air in the rooms so that the next person doesn't get infected. So this is how the aerosol transmits. What about contact? It's very important to know this because a fomite is an object which gets contaminated. So you cough or you sneeze or the aerosol goes and settles onto some object. And the examples are anything, surfaces, toys, telephones, any plastic bags and whatnot. And again, I must say these are based on studies from SARS and MERS. We know that the human coronavirus can survive on inanimate, that means dead objects, remain viable for up to 5 days at a lower temperature, 20 to 25 degrees. But on a higher temperature, it doesn't last as long. So in some ways, in the West, the fomites, it can last more, especially in the winter. And you don't get that so much in India. And it's also dependent on the surface type. For example, plastic, it can last for up to 72 hours, for 48 hours in stainless steel, 8 hours in copper, and so on and so forth. And the rate of clearance of aerosols is also dependent on the ventilation, as I just said. So the faster you have the air change, the more better it is. So if you change the air quickly, it does not settle as fast as you would expect it to do. Okay, so I told you about how you get the transmission, but how long does it last is the next question which we may want to ask. The incubation period, what does that mean? It's a period that you can actually have the infection in you to the time that you manifest symptoms can last up to 14 days. But the median, all of you understand median, is about 5 days. So most people get it around 5 days. But it can, you may develop the symptoms up to 14 days, which is why when you have the quarantine period, you talk about 14 days, because that is the period when you come and start the quarantine up to 14 days. If you watch, the chances after the 14 days are next to nothing. The next thing is patients are most infectious when they are symptomatic, which means when you're coughing and sneezing, obviously you throw more aerosols around. But patients, very, very important, because the WHO gave some wrong information. Patients can be infective even when they are asymptomatic. Some of you may have seen the WHO, and it was trending all over WhatsApp saying asymptomatic patients will not transmit infection. That's complete nonsense, because the WHO retracted the statement within 48 hours, I think 24 hours even, because it does produce asymptomatic patients can. Interestingly, 10 to 40% of patients do not have any symptoms. I'll just give you an example. In our very own we are a trust with 3 hospital sites. We've done antibody tests. Antibody tests, as you all know, antibodies are produced a few weeks after you have the infection. And we looked at antibody tests and looked at IgM and IgG, which comes early and which comes late. We tested approximately 5,000 of our staff, just our staff. Almost 1,250, 25% of the staff in the 3 trusts tested showed the antibodies, which means they were exposed to the disease. But you know what? Only 300 staff in all the 3 trusts developed COVID virus infection itself. So about 900 of them were actually asymptomatic. And the question you need to ask is, how many of them were actually transmitting? And we have enough instances of our staff members who tested positive to our antibodies, did not have symptoms, but their families had developed COVID. So asymptomatic infection, people with asymptomatic infection can transmit the disease. So what next? You know, how do people progress once you have the symptoms? All of you know the symptoms. The symptoms really are the top 4 on the left-hand side. This side, fever is a classic symptom. You get high-grade fever. The fever can last up to 2 weeks. You have a classic dry cough, which can happen in patients. Patients are short of breath, which is the dangerous symptom. A lot of people can be short of breath. The recommendations in India are changing day by day. I keep in touch with my colleagues who are working in different hospitals in India, and we exchange information. Initially in India, for example, they were admitting every patient. Whatever symptom, they're quarantining them in the hospital and quarantining the families and so on. But now I know in Chennai and Mumbai, and Delhi, they are not admitting patients with mild symptoms. They're only admitting patients who have breathlessness or who are unwell and ask them to come into hospital, which is what we did in the UK. We did not admit patients. We asked them to quarantine at home. We only admitted patients who were breathless. And even when they are breathless with the saturation, which is the oxygen levels less than 94%. Most people recover 80% with symptoms which are very mild within 2 weeks. As I said, 10 to 40% are asymptomatic. But the other symptoms, abdominal symptoms, you can loss of taste, loss of smell, and few other rare symptoms like skin changes. You can have arthritis and such like, but they're all very rare. But the first 4 are the important ones. But it's important to note that the severity of the symptoms, if you think about it, even up to 40% of patients, 10 to 40% is the estimate, are asymptomatic. They will not demonstrate any symptom, or they may have a very mild symptom with a sore throat or sniffy nose, may go away in a day or 2. And 80% of patients have mild symptoms. So I think that's a very important message. People are scared that if you get corona, you'll die. You will not die. 80% have very mild symptoms. 10 to 20% of those people with symptoms, were admitted in the UK. And when they were admitted, the mean admission is approximately 4 days. And up to 10% of those patients who were admitted in hospital were admitted to intensive care, and the recovery was between 3 to 6 weeks recovery time. And we all know the mortality rate ranges anything from upwards of from 0.5 to 3% of patients who are admitted. And that changes significantly in people with comorbidities. So, before I go into prevention and treatment, who are the people who are most susceptible? I haven't put a slide on it. All of you are well aware of it. But I just want to make one point. You have on the one side, you have all the diseases that you know of, which is diabetes, blood pressure, heart disease, lung disease. If you have an elderly person, it's much more prone to get it. But one thing which is not often talked about, which I think I must stress on, is obesity. We have seen people who are obese. The mortality rate in obese is about 5 times higher than the ones who are non-obese. So obesity is an independent risk factor in having severity of worse symptoms and even mortality. And lots of data are coming out and looking at the odds ratio, looking at the chance of you developing severe symptoms. And the understanding now is you have an odds of 5 times higher risk if you're obese to develop severe symptoms and death. So in addition to all the other diseases which you can't do anything about, obesity is a very important factor. Very quickly about prevention. We all know this, talking about the distance. We talk about the 2-meter distance based simply on the distance that droplets can transmit. Washing hands, very important. We're talking about 20 seconds because simple soap can take away the proteins on the outside of the coronavirus. So washing your hands, extremely important. You avoid contact, which is very simple. We talk about sneezing. All these things are very familiar, but I just thought that sneezing in the crook of your arm is better than into your hands because you can actually touch things, and we don't touch things with your elbow. You obviously stay at home if you have symptoms, and I think India is going down the route about staying at home. Previously, they were admitting every patient. So I understand that that's what's happening in India. I thought I should put this: prevention and containment, the effect of lockdown. What is the effect of lockdown? People are asking these questions, and we're learning every day. And this is some of this is based on a paper which has just come out last week in Nature, the scientific journal. Some of you must be aware of. And what if you ask me what were the three things that lockdown has enabled us in the UK, and I think enabling you in India as well. Firstly, is getting prepared. So if you're isolating yourself from the lockdown, which is what happened here, the R rate, the R value, or the reproduction number, the number of people that you can transmit to, so is decreased. And therefore, lots of people are not infected at the same time. And if they're infected at the same time, the hospitals get swamped, and therefore you don't have enough treatment modalities to treat our patients. And I must say in the UK, no patient who needed a ventilator was denied a ventilator, certainly in our hospitals and across the country, because we were prepared. So getting us prepared is one big thing about the lockdown. And therefore it prevents the swamping of our hospitals and shielding the vulnerable. That's our patients who are elderly and so on. And this is a study which is just published in Nature. And it looks like in 11 European countries, this is mathematical models, up to 400, just under 500,000 patients, 1 million deaths would have been prevented in Western Europe. And what about the spread of the prevention? About 530 million people, according to mathematical models in China and other countries, have shown that it could have delayed infections. And what it does, as I said, is decrease the reproduction rate. What is the reproduction rate? If you infect one person, it affects another person, and so on and so forth. So if you cut it down to less than 1, if you have a reproduction rate of 2, one person infects 2, who infects 2, and infects 2, and so on and so forth. The doubling rate significantly increases. But if it's less than 1, it's a very significant number because you cut down the spread of the disease, and which is what the lockdown is based on. Very briefly on treatment, there are lots of things we can talk about it, but I will not go into details because we'll run short of time. The first and important thing to say, it's largely symptomatic treatment. What does it mean? The treatment is rest, drinking lots of water, and taking simple paracetamol. There is some controversy about other anti-inflammatory drugs like ibuprofen, diclofenac. but paracetamol works in most people. Symptomatic treatment, as I said, 80% of patients get better. In patients who are admitted to hospital with breathlessness, we give oxygen, and we give them through a variety of ways. And this is an X-ray of a patient who is admitted to hospital. You can see this, the heart. Some of those of you know how X-ray looks, and all these white spots in the lung on both sides are very classic. And when the height of the pandemic in my ward, if I do my ward round, every patient's X-ray would look like that. We don't even need to look at the name. Every patient look like that. And this is a CT scan. Cross-section, transverse section. This is how the normal lung looks, and this is the areas of the lung which are actually filled with inflammatory fluid, what we call as ARDS, acute respiratory distress syndrome-like picture that you would see in patients. So that's how the X-ray looks. We give them oxygen. We give them oxygen in a variety of ways. We give them high flow oxygen. You try and maintain the oxygen levels more than 92% of these patients. We give them drugs, and drugs, no drug to date, except for one drug, I'll come to it in a minute, drugs, oxygen, very, very important, I just said, non-invasive ventilation and invasive ventilation. This is non-invasive ventilation. On the right side, we have a mask without putting a tube in and knocking patients out. It's called CPAP or BiPAP, continuous positive airway pressure, or bilevel ventilation. So you give positive pressure inside to keep the airways open. And this can be done in a good respiratory ward. We do that quite often, and we've just written up a paper on it, on our experience with it. This is invasive ventilation in intensive care when the patients are unconscious. Just to tell you about oxygen therapy is very, very important, because there are two things. We don't want high oxygen. We want an oxygen more than 92%. However you give it, you can give it to this. You can give high flow. But the other big thing, which is a message which should go across, if you get breathless, even at home, please lie prone on your stomach like that. It's an amazing thing. It works brilliantly. Physiologically, the back of the lungs, or the back, has most ventilating units. So you want to keep those units open and perfuse those units. And when you perfuse those units, your oxygenation improves. Interestingly, your oxygen can improve from 88 to 94% within 10 to 15 seconds if you lie prone. And lying prone is not very comfortable, but if you lie prone intermittently, it's a very useful thing. It's a very useful message, which I've been telling the mission hospitals people to do, because when you have low resource, or when you treat patients at home when you feel breathless, it's a very good idea to lie on your prone position. So that's a very key message I'd like to pass across. Talking about drugs, there are lots and lots and lots of drugs in the market, but I must say, as of last week, there's only one drug which has shown promise, and that's an antiviral drug, and we're talking scientific studies which have shown. That's the only one which has shown promise, and we are doing lots of studies in the UK, and I'm sure India is also doing studies. We're looking at different arms, and we are participating in a study called the Recovery Trial, which has got 5 arms in it. And one of the drugs in the arm is hydroxychloroquine. I know India has used everybody's on hydroxychloroquine. It has some side effects. There is no hard evidence as of last Friday that it helps. There are some isolated studies. There are studies which are small studies which have said it helps and it doesn't help. We need big studies. But we also know, I know personally people who have developed cardiac symptoms with hydroxychloroquine, both here and in India. There are other things like plasma from patients who have had the disease, convalescent plasma, monoclonal antibodies, immunomodulators, and combinations of drugs. Lots of them have been used. There is no hard evidence except for this drug as we stand. What about vaccines? That's something we're all interested in. There are 10 candidate vaccines in clinical evaluation, which means we're talking about phase 2 and phase 3 studies. And there are about 126 vaccines in phase 1 and phase 2 studies. So there are lots of them going across, and there are 3 top vaccines. There is the Oxford vaccine, which is up there. They've started trials, but unfortunately, it's been slowed down simply because we don't have enough new cases. If we need to have a randomized study. So you want to inject some people or vaccinate some people and see how many of them develop and how many of the general population develop. So we don't have that much infection now to be actually getting large numbers very quickly. So that is a problem. Then there are other vaccines in the US. So as I said, there are 10 in clinical evaluation and 126 in preclinical evaluation. So this is as of last week and data from the WHO. So where does that leave us with vaccines? I don't see vaccines coming before the end of the year. It will be a miracle if we get it before the end of the year, because we need to make sure it works and also mass produce it. Mass production is not going to be a big problem because I know there are centers which are ready to do it. So I'm not optimistic that we will have it by the end of this year. So I've told you a bit about treatment, told you a bit about the virus, pandemic, how it transmits. And finally, I think my time is almost done. This is something we use because this is a very interesting virus. It has got various presentations. I've had patients who've had transplants. That means they're taking a lot of immunosuppressants to keep the transplants. You know, any patient with a transplant, I've had patients with kidney and pancreas transplants who were admitted, got better and went home. I've had patients who are very well, young people who have died. So this is an interesting virus, and we are learning all the time. So what we do when we treat patients is to use clinical judgment. And for you, what does that mean? I think you and all the people that you know, you should use your judgment, because I presume none of you are doctors, or maybe there are some doctors there. When do you isolate? How do you isolate? When do you get admitted? So, you know, you isolate if you have any symptoms. How do you isolate? You try and keep yourself away from the rest of the family. And when do you admit? India is coming to the stage when you admit when you have symptoms, as in breathlessness, which is getting, when I say symptoms, bad symptoms. So using clinical judgment, and we use clinical judgment, what to give the patient, where to treat the patients, and so on. So the other thing we use is what is the pre-test probability of the disease. So somebody coming with a cough in the UK, for example, in March is COVID. Somebody coming with a cough today is not always COVID. It can be other things like a pneumonia. In India, you're on the stage where it's going up. So you need to think that lots of, any patient with a fever and a cough has to be COVID, or you must keep COVID as a high priority. The other proposal is we treat all possible patients as, any patient walking through as a possible COVID. Because you know the swab test that you do, it's only positive in the false negative rate is up to 33%, which means the sensitivity can be as low as 67%. We may miss 1/3 of patients by doing a swab test. It also depends on whether you do the nose or the throat, how well you do it, and so on and so forth. So it's important to think of every patient, which is why it's useful that all of us have social responsibility. When we not just manage patients for you, it will be manage yourself, your family. Try to social distance. Try not to do the things that you would do otherwise. Be prepared to learn as we gain more experience. We've learned so many things as we went along. Things like how do we treat are very different today than when we started the pandemic. So the good thing is the information is available for everybody. All journals with COVID are free now. You get all articles are accessible. And sometimes we can be a bit intolerant. I've seen the intolerance to, you know, people who, you know, in the UK, the intolerance is really sending the wrong patient to the wrong place and that sort of thing. You get angry with your colleagues. But hold on, we are all in this together. And the intolerance in India, I've noted a lot of people are, you know, you start treating COVID like, you know, when I worked in India, one of the big things was leprosy. And people were so scared of leprosy. And some of our professors, I remember, to teach us how in Vellore, teach us that it is, you can't get leprosy so easily. He used to actually touch the patients and you know, hold their hands with their ulcers to tell us one simple thing, that you can't get leprosy just like that. And it's left a lasting impression in my brain and a lot of my colleagues of my era. So in India, we treat patients as if this is a, you know, you have to be ostracized and people are not allowed to be buried. It breaks my heart. I think we should be tolerant. And that's a message which I would love to be passed across. And finally, where do we go from here? I have only one thing to say about this. I think we should be prepared for the next pandemic. These things are going to happen with our population explosion, with our proximity with animals. It's not necessarily unhygienic things, but there are things which we are close proximity to animals. So zoonotic diseases are very, very common. We've learned lessons, some speculation. Early screening of healthcare workers is something which need to be done, because we can asymptomatic people, we can spread it to others, be treating. Is it worthwhile screening the vulnerable population first? For example, the elderly patients, the diabetics, the hypertensives. Lots of things are there, because you do have the cost of the test and so on. What about governments? Early development of vaccines, antibodies, and joined up working between governments and scientific bodies. It's really happening, but there's lots of speculation whether information from China could have come earlier. We don't know the answer, so we'll just have to say the information came and we're using it now. So joined up working, very useful. And I think this is going to change life for all of us. One of you, your principal mentioned that the way we teach, the way we carry on life may be very different. We've learned how to teach virtually. So this is going to be a thing of the future. So there are some things which are going to change, but I think we need to be prepared about how this changing world will be. And can we say that what is going to be the new normal is very difficult to say, but I think it's very important to note that things will be different in many ways. So I'm going to stop there. I hoped in my talk that I've given you some basic understanding of the virus. As I said, I've not gone into details into anything. Some of this may well be familiar to you, but there are 3 or 4 key messages which I wanted to impart. I've tried to discuss that this is not a new pandemic, that we've had the past, the present, and we need to think of the future. Told you a bit about the clinical presentations in the course of the disease, gave you an idea of prevention really, and more of bits about what we do in treatment, and gave you some speculations about where we go. I'm going to stop there. I'm happy to take questions as and when they come. Over to you.
Hello.
Hello.
Sir, I have one question, sir.
Yes, go ahead.
Is it audible to you, sir?
Yes, I can hear you.
Yes. So, how did the Germans deal with this disease, sir? German mortality rate is very less.
Okay. One of the things that is very important is there are 2 big things. Actually, there are 3 big things. One is the lockdown. How early have we imparted lockdown? So they were prepared to prevent. I told you about the R value, the R reproductive value. So they were able to cut down the R value significantly in Germany compared to the other Western European numbers. So the spread in the population was less. Secondly, they were testing much more than the other countries in Western Europe. So they were able to get an idea of the numbers. Thirdly, they were also prepared. They were well resourced. And the 4th important thing is it's very difficult to compare populations, because we're looking at time intervals. It's well known about temperature, it's well known about humidity, it's well known about the patient characteristic as well. So some of you may have heard that Blacks and Asian groups, some minorities, have got a higher risks. So there are racial differences as well, and there are obviously comorbidities. So I think the top 2 would be they had lockdown earlier, they cut down the R value, and they tested faster.
Sir, can I ask a question?
Certainly.
I heard from newspapers that there was this drug that you mentioned, Remdesivir,
Yes.
from Gilead Pharmaceuticals.
Yes.
It is preventing pneumonia in patients, COVID patients.
Okay.
So is that not the best thing a drug can do for COVID patients, preventing pneumonia?
Okay. So if you look at the studies which have come out, there's a very good study which was published. I think we need to look at the evidence rather than newspapers. The evidence is very clear. The treatment with remdesivir actually cuts down the duration of pneumonia and the severity of the pneumonia. The effect of preventing pneumonias, which means, would I give the millions of people who have got, would we give everybody remdesivir? The answer is, I don't know. We don't know the answer. So it's like, you know, when we had the flu, Tamiflu, which is I don't know what it is called in India, the Tamiflu, which is preventing the bird flu. Yeah, Tamiflu actually cut down the duration in hospital by 0.5 days, by half a day. So the question is, are we going to give the whole population remdesivir? The answer we don't know is now. The answer is no. The evidence so far is not preventing pneumonias, but in patients with pneumonia, you actually cut down the duration of the pneumonia and the severity of the pneumonia. So that is the evidence for remdesivir.
Thank you. Thank you, sir.
Thank you very much, Dr. Johnson Samuel. This was a brilliant session, excellent session. We got so many comments from the chat box that it is excellent information, very useful session from different participants. And thank you so much. As you said, this is a novel virus, and as doctors, you must be using multi-pronged approach to treat this disease. And as you said, there's a lot, more to understand about this virus. What do you suggest for the normal people? How do we equip ourselves so that we can prevent this? Any suggestions, doctor?
See, I think I'll go back to that slide which I showed you earlier. I'm not going to bring it up now. The important thing is to be sensible about it. You can look at it. The first thing is to prepare in the mind. I mean, talking to colleagues in India, talking to family, friends in India, looking at, you know, the newspapers and other things. The first big thing is fear. Okay, so yeah. I would say being mentally prepared to know the disease. Yes, it's a disease, but 10 to 40% are asymptomatic. 80% have a mild disease. It's very important for us to know. So you must take the fear equation out. And even patients with diabetes, you know, I'll give you one of my patients who had diabetes, blood pressure. He's a smoker. He's actually a doctor. He's a 75, a retired colleague of ours. He has got ischemic heart disease, you name it, every single complication. He was admitted with bad lung disease. We treated him with CPAP. He improved. He's gone home perfectly fine. So he's got about 10 reasons to die.
Yeah.
Even if you've got all these diseases, I've told you about transplant patients. I've had numerous patients who had transplant on high dose immunosuppression, which is just the disaster for the virus can. So they've got a higher chance than somebody who doesn't have it. But even people with that have been discharged home. Well, so everybody, even with a bad, you know, comorbidity, need not die. So the first thing we need to prepare ourselves is remove the fear, which I think is a big thing. The second thing, what can you do, is to be sensible, to prevent. I told you about the prevention things. Social distancing, you know, I've seen, you may turn around and say, in India, it's very difficult. I've seen pictures of my parents live in Chennai, and about the Convenors market you're talking about. And it was all over the newspaper, all over the world, saying how it's a hotspot in a market. I mean, it's important to educate people that in some patients it can be sick. So therefore, we shouldn't be taking the chance and saying, oh, let it come. We need to be sensible about social distancing if we can do it. And obviously, the most important thing is to take care of hygiene, washing your hands and wearing the mask when you go outside. At least prevents the droplets from coming in. Is there anything which helps you tablet-wise to prevent the disease? Now, again, people take, zinc and selenium and antivitamins. There's nothing wrong in taking it. But do we have evidence to say taking zinc prevents this many COVID patients? The answer is no, we don't. But is there anything wrong in taking selenium and zinc? The answer is no. So if it's available, take it. What about vitamin D is the other thing we're talking about. What does vitamin D help? Now, in the West, everybody is deficient in vitamin D. We don't have any sunlight, first of all. So people have taken vitamin D. But do we have evidence to say vitamin D has prevented this many COVID disease? The answer is no. But if it's not going to do any harm, can you take it? The answer is yes.
Okay.
Going to another drug, hydroxychloroquine. Now, we don't know whether it prevents, is the answer. That's the scientific, we don't know hard evidence. So just because you take hydroxy, 5 of you take and all of you haven't got COVID doesn't mean. It's like tossing a coin in statistics. What are the probability of each time getting heads or tails? So we need to have proper studies to say it prevents or not prevents. I personally know even one colleague in India who was taking it, who developed cardiac symptoms, had to stop it. I don't know anybody who's died personally. You may argue saying, hydroxychloroquine is used by lots of patients with malaria, but we use it for every drug has got its risk and effects. And I personally, if I get COVID, I'm not taking hydroxychloroquine. It's available to me. I'm not taking it because I don't know is the answer. And I do know that 80% will get better. So I think we need to be sensible. Is there anything you can take to, boost your immunity? The answer is, exercise always helps if you can do it safely, because exercise is a good immunomodulator. As you know, it gives you certain immunomodulators which will help.
Yeah.
You talk about herbal remedies. We can go on and on. Things about turmeric, for example. Well, turmeric has been, we don't have any hard evidence, but is it going to harm you? The answer, I would say, is no. Am I taking turmeric? My wife actually gives me, she mixes turmeric and lime juice and lime and ginger. I drink it in the morning and evening. Well, it doesn't harm me. I don't know if it's helped me, but I take it. So that's my advice, how to.
Oh, thank you very much, sir, for the valuable information you have given. And there's one more question.
Okay.
Sir, why are a few patients asymptomatic even when they have the viral particles? Some of the patients, a few patients are asymptomatic, and why is it so? Okay.
That is a very interesting question, which we don't know the answer for. Is it, is it because they are young and fit? The answer is no. The answer is no, because there is an unpublished study in the UK. It's called as the Easter 6 care home study. So when they looked at, they screened patients in 6 care homes. In these care homes, there are older patients, some of them with dementia, who have some chronic illnesses and such like. They found that about 25% of patients who were screened in these care homes had the disease, and about half of them, these very unwell patients, not unwell, they are frail patients, were asymptomatic. So we don't have the answer saying only fit people will get it. And on the other hand, we have lots of young people who have died, who are others have no comorbidity. So we still do not know, but we know one thing: the severity of the disease depends on your cytokine response. That means how your body reacts to an external stimulus. So why do people get ARDS? It's because of the significant cytokine response to the virus, and that's the inflammatory response which hits your own cells. And we also know we are all genetically different. There's some of us, if you take a vaccine, you produce lots of antibodies. There are some people who, for example, the classic vaccine is your hepatitis vaccine. Some people are non-responders. They don't produce enough antibodies, while others are hyperimmune responders. So we are all genetically different as well. So it's very difficult to speculate and say it's genetic, but there's a bit more than that. So we don't know the answer to it.
Yeah, thank you very much, doctor. It has been a very interesting session and a very useful session. Thanks a lot from Andhra Christian College. And,
Thank you. I'm delighted to have taken part.
yeah.
I'll soon get to work. And I
Yeah.
wish you all the best for the rest of your seminar. Thank you, Dr. Ezra and Dr. Susan, for your
Yeah,
time.
thank you, sir.
Thank you very much, sir.
Thank
You're
you.
welcome. I will be leaving the meeting as we speak.
Yeah.
Thank you.
Bye. Thank you.
Thank you.
Dear participants, we will move to the second session. The second session is addressed by the lecture by Professor T. Bala Murali Krishna, and the introduction of the resource person will be given by Mr. Y. Sudhakar Reddy, Senior Lecturer, Department of Physics. Is Sudhakar Reddy available?
Yes.
Yeah, Sudhakar Reddy, proceed.
So, hello everyone. Welcome to the second session on future classrooms. I have a very pleasant duty of introducing today's resource person for the second session, Professor T. Bala Murali Krishna, Head of the Department of Computer Sciences, Sri Sarita Institute of Engineering and Technology, Nuziveedu. Professor Bala Murali Krishna is from Nandigam, Krishna district. He did his schooling in Nandigama, intermediate in Penuganchiprolu Junior College, BSc in Computer Science from KBR College, Nandigam. So he did his BSc in Computer Science from KBR College, Nandigam, and then MSc in Computer Sciences at Hindu College, Guntur. And then he moved to M.Tech in Computer Science and Engineering at Nirmala College of Engineering and Technology, Vijaya. He did his PhD in Computer Sciences and he awarded PhD in the year 2018 from Bhartiyar University, Coimbatore. Professor Bala Murali Krishna is having vast experience in teaching computer science. He worked as Associate Professor and Head of the Department of MCA, Sri Sarita Institute of Engineering and Technology from 2001 to 2010. Between 2010 and 2014, he worked as Associate Professor and Head of the Department of Computer Sciences, Paladugu Parvati Devi Institute of Engineering and Technology, Surampalli, Vijayawada. And now presently he is working in Sarita Institute of Engineering and Technology as a Professor and Head of the Department of Computer Sciences. Professor Bala Murali Krishna attended a number of workshops, faculty development programs, and conferences in computer sciences. And he published a number of papers in national and international journals. Today, he is going to deliver a lecture on future classrooms. Sir, we are all eagerly waiting to have from you about technology-rich classrooms. Now, I am inviting Professor Bala Murali Krishna to deliver his lecture. Thank you.
Good morning, one and all. Honorable management members, AC College, respected Principal Sir, Principal Madam, heads of various departments, my dear colleagues, professors, and dear participants. Welcome to our webinar session today. Today, I would like to share some of the information with you about future classroom. Right. We all are familiar with classrooms. And now, today, in this pandemic situation, because of COVID-19, we all are participating in different kinds of webinars. We are participating in faculty development programs through online. So this future classroom is also one kind of online class. The information that I am going to share is how would be the future classrooms what are the expectations of the students and faculty based on the technology. Now, all of you see the picture on the screen. Here is one kind of classroom which is equipped with digital board, and students are using, in place of books, tabs, laptops, and this classroom also equipped with some other kind of gadgets. We can call this classroom as a classroom with technology. This is one kind of classroom we can expect in the future. And the backbone for this technology is obviously internet. Next kind of classroom I would like to discuss here is an online classroom. We are presently using video conferences, apps like Zoom, GoToMeeting, Google Apps, and all. These all are comes under the example of online classrooms. These classes uses basically internet and some advanced apps and softwares. So to create this kind of environment, obviously we need an internet facility. We all know about internet very well. We can call it simply as net, which is a worldwide system of computer networks. The word internet changed the shape of the world drastically in the area of engineering, in the area of medicine, in the area of research, even in the stock markets, manufacturing, and even marketing. Everywhere, if you observe, the internet nowadays playing a vital role. Obviously, computers plays a vital role in each and every area of specialization. In this connection, now I would like to reimagine the word education. We are learning through education. What we are learning nowadays, probably we are learning technology. This technology is going to be developing in large in all the fields and applying in the small, especially in the education field. If you observe, the education has not really changed. The education has not really changed from past 500 years onwards. Therefore, this is the correct point. We need to discuss about some technologies which plays a vital role in education system. Today, I am going to cover 3 interrelated topics. One is virtual class, second one is MOOCs, and third one is I am going to discuss with you is LMS, Learning Management System. In this system, I am going to take one online real example called Google Classroom app. Right. Let me allow to discuss and to define what is virtual classroom. If you observe the picture on the screen, students are geographically dispersed and teachers are also geographically dispersed, but all are connected to one with another, having a illusion that they all are at one place. This software and this technology creates an environment like we all are at one place. Such an illusion is called virtual. Therefore, such classrooms are said to be as virtual classrooms. Technically, what is virtual classroom? A virtual classroom is an online learning environment that allows for live interaction between teachers and students as they are participating in the learning activity, that is teaching learning process, which is online. So here we need to create a blended model of education system. especially in India, we use kind of blended models of education system. One of the model is self-learning system. What is self-learning system? You observe the picture here. There are three kinds of learning methodologies are going in the classroom. One group of students interacting with the faculty, and they are sharing information with the faculty. They are clearing their doubts with the faculty. And one girl is separately working with the laptop. She is learning by her own through internet connection. And aside, one boy is also working with the laptop, desktop. He's trying to communicate with his friends to know about knowledge, to share about knowledge. So, especially in Andhra Pradesh, KLU-like universities, Geetham's University, and some other private universities actually started this kind of blended models of education system called self-learning system. Here, we can transform education both in quality and scale of access technology. So, based on this, once again now, we all reimagine and re-engineer the education system. That means certain things has to be changed. What are those changes? Infrastructure has to change. First of all, we need to change. Everything has to change. So we need to move from lecture on blackboard to online videos. We have to move from hands-on laboratory system to the online software tool usage for laboratories. And we have to interact online. We need to create discussion boards, everything online. Everything really has to change. In Karnataka, in one high school, teachers flip the classrooms. They allow the students to learn by their own. It means they are using an online kind of a softwares. Those softwares allows the students to interact with the colleague students online. They can share the information online. They can solve the problems online. They can even meet their professor online. Everything is online. At the end of the results, they found that the results was improved by 8 to 10%. So here, what we are doing, we are creating blended kind of models. We are allowing the students to involve in the education system. We are allowing the students to solve the problems by their own. Therefore, they are doing very well. And as I said, this kind of classroom environments are said to be as virtual classrooms. One is a classroom equipped with technology. Another one is classes through online. And this is about the first topic called virtual classroom. And now I would like to move to the second topic, MOOCs. This is a 4-letter word, actually introduced in the year 2008. So 1.5 decade onwards, the world is focusing on this kind of courses. Let me abbreviate what is MOOCs first of all. MOOC stands for Massive Open Online Course. Massive Open Online Course. Actually, it is not a course offered by the college. Even it is not a course offered by the universities. It is an online distance kind of a course. It is online distance kind of a course. M means massive. Many number of students can take a course at a time. Probably more than 1 lakh students can register for it. And it is open for anyone. It is no pre-qualification is required to register for this kind of courses, and who are having internet connection can learn for free, therefore which is a online, and this course is similar to distance kind of a learning. At the end, you can have credentials of it. You can get the certificate through online and all. Now, let me allow to discuss the importance of the MOOCs. As I said, MOOCs is a online kind of a distance course. The advantages are we can listen to the excellent professors of great universities through online. The resources of the university through online, that is software, that is tools which are very costlier. We can just log into the website and we can use them freely. And MOOC is a free web-based distance learning program. This course is designed for the participants of large numbers of students who were dispersed geographically. The 4-letter word MOOC was introduced by, excuse me, MOOCs was introduced by Dave Cormier from the University of Prince Edwards. As I said, it is an online course for free of cost and open registration. It is a course encourages the students through online who have a self-discipline, and they can took up this course to reach their goal and to acquire knowledge as well, skill. And coming to advantages and disadvantages of this MOOCs course, as I said already, no tuition fees is required. It is open access for all of us. We can listen to the excellent professors. You can download the excellent material prepared by the excellent universities throughout the world. Students can collaborate with other peer students. They can share their knowledge. They can pose queries. They can get answers through online. And all these are the advantages of MOOCs. And coming to the disadvantages, this kind of course is not suitable for a lazy students, and there's a chance for dropout. And these MOOCs do not provide active feedback due to large number of students. There is no active involvement by the professor with the students. The professor cannot take personal care with the students, and there may be a chance to have a technical problems like internet problem, device connectivity problem, and data problems. And now I would like to move to the third topic called learning management systems. As we have already discussed, two important kinds of softwares. One is virtual classroom kind of softwares. Second one is MOOC kind of web-based softwares. These two, the features provided by these two courses, we can use in this learning management system. What is learning management system? It is a state-of-art software tool used to train the teachers, even fresh teachers or trained teachers, and we can train the students through online who are dispersed geographically. And this software, corporate style of a software, is installed in the server. We will allow the faculty to register into this server. We will add the students into this server. We can create the classes online with the help of this. Can do the following functionalities like user management. That is, we can create the user IDs for our students. We can make them groups. We can delete them. We can add them. Second feature is online course management. That is, we can add our employees into this course. We can allow the faculty to create their videos, to share their text with the students. And the third facility is tracking of courses. The management can check the status of the completion of the syllabus. And there is one important facility called online assessment. We can conduct the examinations through online, and we can take the feedback from this LMS software. So there are three kinds of interrelated topics that I have just defined. One is virtual classroom, second one is MOOCs, and third one is the LMS. Now, let me allow to discuss another important point of the online classroom. In one university, that is in America, the name of the university is MIT. They have launched the first course, that is an electronic course 5 years ago, which is a online course through edX web. They have invited registrations all over the world. The students were get registered from 162 countries. And the strength of the students is 1,55,000. The number is very big. After completion of this course, approximately 7,200 students were successfully passed, because this electronic course is a tough course. And if I was the teacher in the MIT, in a year, we will be having 2 semesters. I would have to teach for 40 years to reach this much of big number, that is 155,000. So the main advantage of these online courses are many number of students can register. They can took up the course at a time. Before going to in detail, let me tell you one story. In present days, these millennium students are very fast. One father is discussing with his young daughter. She is about 15 years. I can call it as a teenage. She started speaking English. She began speaking new language, that is T language. It has 2 sounds. The new language, T language, has 2 sounds. One is another one is silence. I repeat it, there are only 2 sounds. One is another one is silence. The father is trying to communicate with his daughter. Honey, come for dinner. She replied, He again asked, did you hear me? Then silence. Can you listen to me? He really shocked. He was unable to communicate with his daughter nowadays because all the millennium students are busy with their apps by using their cell phone. So at the end of the day, he found a solution for his problem. He texted her. He got instant reply. Again, he texted. He got instant reply. Since then, their communication has been changed. He started texting her. She started giving reply to text only. It is great. So what I want to tell you is, for these millennium students, they are having skills to use this kind of online courses, and they are very much familiar with using this kind of apps. Really, we all need to think about online technologies nowadays. We have to blend them, we have to use them. Rather, rushing into the classroom morning in the 8 o'clock, we can start using this kind of online technology for teaching the students. Now, I would like to propose a few important key ideas regarding these online courses and future classroom technology. They are learning process, self-learning process, instance feedback learning process, gamification learning process, and finally, pure learning process. These all are the 5 key ideas. We can use them in online. What is active learning? So here a professor can prepare a video lecture and he will send to his students. The student listen to that video. They will interact with that video. They will learn much better. And such kind of learning is said to be as active learning. And second one is self-learning. As I said already, even in Andhra Pradesh also, we are using this kind of self-learning technology. It is really useful. They can learn much better. Next, third one is instance feedback learning. Here, computer plays a vital role. It creates some programs. So when the student is trying to interact with the program, he has to give the answers to the questions. If really he gives the right answer, then only it moves to the next screen. Such kind of an interactive learning is said to be as instance feedback learning. Next, gamification learning. We all know the computer-based games. We can create lectures, we can shoot them, we can write a program in such a way that which create interest to our kids so that they can learn interestingly. And finally, the pure learning is a teacher can upload his videos, a teacher can share his text kind of a material, he can conduct an online examination, even he can evaluate the exam online. So these are the kind of a key learning processes we can implement through online. And finally, I would like to request all of you again reimagine about the education. We will have to need to move from lecture halls to the e-spaces. We have to move from books to the laptops. We have to move from school buildings to the digital dormitories. So probably in coming 1 decade, we may expect this kind of classrooms. Or knowingly or unknowingly, in this pandemic situation, because of COVID, we all are using online technology for seminars and classes to interact with the students. Now, I would like to show you an example software which creates this kind of environment. I'm going to explain about a Google Classroom. The first step is all of you go to the Google, select a Google Chrome, type google.co.in. Go to Google Apps. The second step is go to Google Apps, select Google Apps icon in the Google homepage. There are several apps to select. Now move to the app called Classroom. The third step is select a Classroom app. Once you select, it appears like this. The first step we need to do is we have to create a class. Here is a plus symbol. Select the plus symbol. There are two options. One is a join class. Another one is the create class. We have to choose create class because first we have to create the class, then we will allow the students to join into the class. So select the option called create class. This message, actually, this app could be used by schools and universities with their email ID. We can also use it for demo purpose. Select tick here to accepting rules and regulations of the Google Class app. Click on continue. Now we are going to create a classroom. Second BSc Computers. Name of the class is Second BSc Computers. Section is A section. Subject is Introduction to C language, C programming language. Here there are 4 fields to create the class. One is the name of the class, one is the section of the class, third one is the for which subject we are creating this class, and room number. Click on create. It takes some time to create the class. We can call it as a virtual classroom. As I said previously, this Google Classroom is a virtual classroom. Right. After creating this classroom, the students can join into this class by using this password or class code. All of you observe here, every class has a code. Here the code is PVLH24Z. So we are the admin, that's why we are creating the classes. If the students or faculty wants to enter into this class, they can use this code by selecting the join class. Right. So here you can change the appearance of the classroom. There are select theme. You can click here. There are several themes related to class. Whichever theme is related to our class, you can select that one. Because I have mentioned the name of the class as the BSc Computer Science, I am selecting the laptop icon. Select this icon. Select here button, select class theme. The appearance of the classroom was changed. So now see here, all of you, after creating the class, there are 4 options. One is stream, which we have already created. Second one is classwork. Third one is people. And fourth one is the marks. Now, let me allow to add people into this class. What is our class? Second BSc Computers. Right. Here there are 2 options. We can add the teachers into this class we can add the students into this class. Select this human icon. You can invite teachers. Click here. Type the mail ID of that particular teacher. Selecting one mail ID. balu.39@gmail.com. This is one mail ID. I am making this person as a teacher. Click here, invite. Likewise, we can create as many as teachers required for this class. And similarly, we can add the students. For example, Balu_30, it is another mail ID, which I am making it as a student. Click on invite. Likewise, we can add number of teachers into this class. We can also add as many as number of students they are belonging to this class. Now, we have created a classroom with the option called stream. We have added people, few people like faculty and few people like students. So therefore, you can add as many as required. Now we will see how these teachers and students interact virtually. For that, we have to choose an option called classwork. So here, there is an option called create, which is appearing with plus symbol. Please select an option called create. When you click on create, there are actions that we need to do in the classwork. First action is assignment. We can give assignments to the students. Second one is we can give quiz assignment to the students. We can give questions to the students. We can share materials to the students. Let us select assignment. Right. Title of the assignment. Introduction to add files here. We can also add files from YouTube. We can upload video files. We can upload Word files. I am selecting for assignment as a problem solving using C language. Press here, upload. It takes some time to upload the file. Once this file is uploaded, we can assign this work to the students. See here, right side topmost corner, assignment. Assign to all the students in the classroom. A message is sent to the student's mail ID. Soon after receiving the mail, the students can log into this class and they can open this assignment. Likewise, we can also create quiz assignment. See here, title of the we are preparing the questions. Who is the father of the computers? This is a question. We can give options here. Select multiple choice. Option 1. Give one name, Krishna. Option 2. Venkat. 3. Babbage. Option 4. None. Create. Likewise, we can create as many questions as we require, and we can ask to finish this task. Therefore, a mail has been sent to the student. He will receive the mail. When he opens the mail, he will redirect it to the question paper directly. Likewise, this app is a very user-friendly. Even we can create meetings online using this app. We can schedule the meeting, for example, 16th afternoon 1 o'clock. If we want to conduct a meeting, select add Google video conference. And press the button save. This event was saved in the calendar, and a message is sent to the students or faculty. Simply, if they open the mail, it allows one button, join. If they presses that button, they can directly come into the video conference. Therefore, this kind of environment is said to be as a future classroom. Now, I would like to show the best softwares that are available in the market, just like a Google app, or is Canvas. Second one is SAF Litmus. Third one is Blackboard Learner. Next, see here, Google Classroom. What we are using is a trial version, and this is a purchased version. Original version, we need to purchase this software. Schools, universities can purchase these softwares and they can install in the server. They can create virtual classes. They can create interaction between lecturers and students. There is one more example, Disibo. And here is one more example, Talent, LMS. These all are the top available LMS softwares. You can see, you can find them in this link. If you type this link, you will get best learning management softwares in the Google. And similarly, the best MOOCs courses offered worldwide. I am giving few links, please note down. By the university. Second one is Iversity. Third one is the Elson. Fourth one is Open Learning. And fifth one is Coursera. And sixth one is Udacity. And seventh one is edX. And eighth one is EduQuart. These are the addresses of these websites, we can log in into these webs. We can register the courses freely. There are different kinds of courses are available. Some are related to science and some are related to the technology and some are related to the medicine. So as I said earlier, this is the information regarding the future classroom.
Madam, okay, madam.
Unmute. Thank you, Professor Bala Krishna. You have enlightened us, all the participants, about the future classroom. Thank you very much from all the participants. It's very interesting. And I think in a matter of 1 or 2 years, everybody will be using all these tools, especially what I've mentioned, the MOOCs and everything. All these are very interesting. Thank you very much. I'll see if there are any questions in the chat box and come back to you. Dr. Bala Krishna, are you there? Mute ayina chudamma.
Hello, hello. Yes, sir.
Hello.
Yes, sir. Yes, madam.
Hello, Dr. Bala Krishna.
Yes, madam. Is it audible?
Yeah, yeah. Thank you very much. It has been a very interesting lecture.
Thank you, madam.
We learned a lot from your lecture. It was an excellent presentation.
Thank you,
And
madam.
thank you very much from the participant side. Thank you.